everyone, I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little about us, SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today, our technology is embedded in next-generation vehicles, leading the way towards human-centric mobility through driver monitoring systems and interior sensing solutions. Our research instruments offer unparalleled insights into automotive, aviation, assistive technology, behavioral science, and many more fields. Today's episode features two SmartEye team members, Mario and Aaron, discussing the transformative potential of SmartEye's eye tracking solutions and redefining the possibilities of automotive research in a recent live virtual event. Attendees discover the essence of eye tracking, its profound relevance, and how it enables breakthroughs in road safety, human-machine interaction, and human factors research. Let's listen in to learn more. Okay, welcome. Thank you all so much for joining us for today's webinar, Revolutionizing Automotive Research with SmartEye Pro. My name is Ashley McManus. I am the Senior Director of Global Marketing at SmartEye. But SmartEye's mission is to revolutionize human-machine interaction, and our technology helps researchers understand the cognitive processes that guide people's behavior and decision-making. And our data-driven insights offer a deeper comprehension into the human mind. So in addition to the human-centric mobility insights that our advanced eye and head tracking tech can provide, I'd really love for today's presentation to convey the unobtrusive flexibility of our SmartEye Pro. So if you're a part of a university lab, an automotive researcher, or you're just really passionate about new tech in the automotive industry, this will also be a great opportunity to ask questions of the experts that we have here today. So with all of that being said, I'm thrilled to host both of our own expert speakers today. We have Mario Gomez, Sales Director at SmartEye, as well as Aaron Galbraith, Customer Satisfaction Manager at SmartEye. So I'm going to have Mario begin now, who will give a more comprehensive introduction of himself, SmartEye, and the wide-ranging applications of 3D remote head and eye tracking in automotive research. And I will see you at the end. So Mario, take it away.
Hey, thank you, Ashley. So hello, everybody. We appreciate you joining us today. So as Ashley mentioned, my name is Mario, and I'm part of the Research Instruments Unit at SmartEye. On this call, I also have my coworker, Aaron, with me. And together, we plan to show you how SmartEye Pro, which is our flagship product of research instruments, can be used to run a successful automotive research. I will quickly give you an overview of our company. Then I'm going to dive into SmartEye Pro and its specifications. I will explain the types of data that you can get with the system. And following that, I'm going to let my coworker, Aaron, explain the 3D world model feature that we offer and the different research environments where SmartEye Pro is often used. Finally, we're going to open the floor for questions. Hopefully, by the end of this webinar, you will have a clear idea of how our technology works and why SmartEye Pro is the best eye tracking solution when it comes to automotive research projects. All right, so a little bit about our company, if you don't mind. Our headquarters is in Gothenburg, Sweden. We are a company of 300 plus employees. We are a public company in Europe. We carry more than 20 plus years of experience. We have a global presence, meaning that we cover all continents. And today, we are also happy to say that we have Affectiva and iMotions under the SmartEye umbrella. I'll talk more about each one of them in the next slide. And finally, I want to mention that as of today, we work with more than 20 OEMs, and we have more than 1 million cars on the road using SmartEye technology. All right, so this is how we operate as a company nowadays. On the far left, we have Automotive Solutions, which is the unit responsible for our Tier 1 part of the market and technology. Following that, we have Applied AI Systems, which is the division responsible for our DMS solution for fleet and aftermarket. Right in the center, we have Research Instruments, which is the team that Aaron and I work for. Our goal in this unit is to develop the best eye tracking solutions for advanced research and training applications. Media analytics is represented by Affectiva, who's also the leader of the emotion AI market, and we apply Affectiva's technology to our own automotive solutions. Finally, we have Emotions, who offers a hardware-agnostic platform that integrates and synchronizes multiple biosensors such as eye tracking, EEG, ECG, and facial expression analysis, all of that into a single UI, a single software. Emotions can also be used to analyze the data generated by Smart Eye Pro. We'll talk more about that later. So now it's the fun part. We're about to dive into research instruments. And as I mentioned before, our goal within this unit is to develop the most advanced eye tracking solutions for advanced research. Today, we plan to focus on automotive research, as well as the different automotive research use cases that we come across. However, I also want to mention other industries that we also happen to be present. As you can see, when it comes to research, we are not limited to a specific industry or application. And one of the reasons for Smart Eye Pro popularity lies on the fact that it's considered to be a non-intrusive head and eye tracking research solution. And what is amazing about Smart Eye Pro is that it avoids the physical discomfort that is oftentimes caused by coming in contact with a device, like a headset, for example. In other words, the naturalistic feeling that you get with this product makes Smart Eye Pro very popular amongst different industries. And over here, I have a few examples, such as, automotive, aviation is a big one for us, psychology, neuroscience, medical and surgery, and so on. All right, so now a little bit about the general specifications of the system. So Smart Eye Pro is a multi-camera system that runs on a single PC as well as a single algorithm. It is scalable for 1 up to 8 cameras. And the option to scale really allows you to increase your head and eye tracking field of view. In other words, you are never limited when it comes to movements. The placement of the cameras can be very flexible, and the subject can be as far as 3 meters away from the cameras. Obviously, the farther you are from the cameras, the less data you might get. However, if you're doing automotive research, I assume that the driver is not going to be so far away from the wheel. We offer the best combined headbox, field of view, and gaze accuracy in the market. We say that under ideal conditions, you can get an accuracy that is lower than 1.0 degrees. We give you 145 head and eye measurement parameters. And because we use IR illumination, the cameras are insensitive to ambient light, which is something that really allows you to increase your research possibilities. So this is a picture of Smart Eye Pro in action. This was almost a sunny day that we had in Seattle. And the driver here is actually Aaron. If you take a look at this picture, you see the same camera that I had in my previous slide. For this car, we installed a 3-camera system. You can see 2 of them here. And in case you are wondering, if you have the experience, if you know how the system works, it takes maybe 30 to 40 minutes to get this set up running. When you're not familiar with the system, it might take a bit longer to set it up. But in any case, we can always help you when setting up the system for the first time. All right, so here we have a basic explanation of what is a complex process per se. So in this illustration, you see 2 cameras. We have one on the left and one on the right. All right, each one of the cameras here has a flash. We need the flashes to create a reflection in the eye's cornea. And that is how we build a triangulation of the head and the eyes. We also track each one of the eyes separately as a way to get a more accurate and robust tracking performance. Here, we have some of the types of data that you can get with Smart Eye Pro. We give you all the data related to the left and right eye, head position and rotation, gaze direction, gaze intersection, eyelid opening, blinks, all the data related to pupillometry, such as the diameter of the pupil. And for analysis, we give you fixations, saccades, etc. Again, we give you over 145 different parameters. You can also stream the data through TCP or UDP. And if you wish to know more about the specifics of that, please feel free to shoot us an email once we finish the webinar. It's going to be a pleasure to be of assistance. So it is difficult to list all the different use cases that we come across in the automotive research industry. But here I have some of the main ones. We have research on driver distraction, better recommendations for vehicle design, UI, UX, the effects of prescription and illicit drugs on driving. I actually have a customer here in Massachusetts who ran an impaired driving research, and it was very interesting to see that. Other types of use cases could be evaluation of the interactions between drivers and integrated vehicle technologies. And you can also use Smart Eye Pro as a reference for testing other embedded eye tracking solutions. So we don't have the space or the permission to show all the logos, but our research eye tracking solutions are present in more than 500 labs around the globe. So I guess here is the part where I let Aaron take over. So I'm just going to bid you farewell just for a few minutes. Aaron.
All right, thanks, Mario. So this slide basically goes over the concept of what we consider 3D remote multi-camera eye tracking. So there's a lot to unpack here. So let me try to explain what all these various words mean. First of all, note that Smart Eye Pro is a head and eye tracker. So we track the head as well as the eyes, and we can track them independently. Data surrounding the head, for instance, are things like what's the direction of the head, the heading of the head, the pitch, the roll, the tilt, etc. And then we can track data surrounding the eyes, such as things about eyelid opening, pupil diameter, gaze origin, all of the various gaze intersections on different 3D wireframe models that we call our world model. You can see a couple examples of the world models here on this slide. So in the bottom right corner, we have an example of an automotive world model. And in the upper right corner, we have an example of an aircraft simulator world model. All of our data is measured with respect to a world coordinate system origin. So we have to create a single point of origin where all the data can then be relative to that. And this origin is freely placeable in the environment. It can be rotated, flipped, and manipulated to be placed over any other existing origin. For example, I know in the automotive industry that a lot of automotive origins tend to be between the front wheels with the positive X direction of the three-dimensional origin pointing out the nose of the front of the vehicle. That's not the basis of our system. Our system is pointed towards the subject, but we do allow you to rotate the origin and manipulate it in any way to align the data. So this makes it easier for the data that's being collected from Smart Eye Pro to be coordinated and collated with the data from other sensors in the vehicle. So having a well-defined origin gives us the ability to recreate the entire vehicle environment. And that's kind of an example we're trying to show here on the slide in the images. So we do create this 3D world model that's based on our world coordinate system. So again, that origin. It's a wireframe model. This represents the real world or simulated environment. So we'll select an origin, and then all of the three-dimensional data is reported relative to the origin. The origin, again, can be placed freely within the environment. It is customizable using various 3D objects. We have objects like cube, sphere, cylinder, plane, and a screen. And then what this allows us to do, if you take a look at the bottom right image there, you can see the green circle is the subject's head, and they are looking through the windshield in this case. And in the upper right image, again, the green circle, or really it's a sphere, but two-dimensionally looks like a circle, is looking through probably the MFD in the cockpit. So here we have a video. This video is going to describe the interface. It's going to describe Smart Eye Pro a little bit. So we can see as he's moving around, you can see the green sphere in the bottom is moving. He's looking at various objects in the environment, which highlight and light up as red. And also he's looking at those while moving his head quite a bit. So as I mentioned before, the system does head and eye tracking. So we can track the two independently, and it gives us a much better gaze tracking capability. This example is showing video recording that is collecting the Smart Eye Pro output data and then drawing the gaze vector over top of the video itself. And that's what the blue dot or the blue ball is here, is where is the person who's driving the vehicle looking currently. Okay, so if I go back to the beginning of the video here, what I'd like to talk a little bit about is the interface for Smart Eye Pro. So what we can see in this example is the bottom shows our three-dimensional world model. Again, you can see the object that's red that lights up is the object that the subject is looking at. And the green sphere or circle in this case, it looks like, is the head of the subject. The upper portion shows the 4 cameras in this instance. So we had 4 cameras in the system, one near the driver's side A-pillar, one near the passenger side A-pillar, one near the center of the dashboard, and then one down towards the bottom of the center console in order to capture gaze down towards the center console as well. There were some terms that popped up during this video. We had like naturalistic. What we mean by that is having the ability to remotely locate the cameras. So as Mario mentioned a little bit before, the subject doesn't have to wear anything. They can act as they would. So it gives them a much more natural interface with their own environment. And the data then can be considered more natural. We also discussed a wide field of view. So in this example, the subject can view from the side mirror to the side mirror, as well as from the top of the windshield to the bottom of the instrument cluster. Another term that popped up was large head box. And when we talk about the head box, we talk about the viewable area for the head. So you can see the subject is in all 4 of the camera images. Their head is in the middle. And as they move around in the video, we're able to track them within a very wide field of view, as well as movement ability. So, within their natural environment, they would be easily tracked by our system. We also mentioned that it's accurate while moving. So I talked a little bit about that while the video was up, but because we track the head separately from the eyes, it's possible for somebody to look to their left and point their nose to the right, and we can tell you that they're doing that with the data that we output. When we went to the video, we were talking about tracking outside of the vehicle. So this is using another tool that Smarty offers. It also can be performed through the iMotion software. And we can merge the eye tracking data with a scene-based camera to display where the subject's looking out into the environment, as we were demonstrating. Okay, so this slide shows various environments where Smart Eye Pro is currently being deployed and used to track subjects. So we have a couple simulators shown here. So we have automotive simulators. We also have customers in the semi-truck industry that use us inside their simulators. We have aircraft-based sim, both fixed wing and rotary wing, military, non-military applications as well. Also boats, ships, and some of the command centers. That's not actually pictured on this slide. We have an example of a control room or operator setting. Train conduction, which is actually the bottom right-hand side, is tracking the information around how train conductors work. And from a real-world perspective, we've been used in automotive as well as semi-trucks. So simulators are typically in a room or area that has controlled lighting, so it makes it very easy for our systems to work. However, when you get out into the real world, you have things like sunlight and darkness. And because we generate our own infrared light, ambient light doesn't affect us. Even in a simulator, if you were to turn all of the ambient light off, our system would look exactly the same. It would track exactly the same. So even in direct sunlight or pitch darkness, the system operates the same manner, and the data that we output is unaffected. What will change, for instance, are things like the pupil dilation of the subject. It's an example of driving on a road, maybe in the Appalachian Mountains, and you go through a tunnel. So we go from direct sunlight into darkness, or mostly darkness within the tunnel, and you will be able to collect data without any interruption. So I'll talk a little bit about iMotions. So iMotions is a biometric analysis platform. And from Smart Eye's perspective, this fills a nice void for our Smart Eye Pro customers who are looking for nice polished video and data processing software. It works actually with many biometric sensors. We get into things like eye tracking, galvanic skin response, EEG, EEC, EEM, facial expression, emotion detection, recognition, etc. So this platform provides a way to flatten all of the data from a timing perspective in order to perform analysis, annotation, and data exporting, amongst other things, with the system. From the Smart Eye Pro perspective, we're just one of the many sensors that iMotions can take in and collate the information for.
Awesome. I'm back. Great presentation. Super fascinating. So do you always need a 3-cam system for a research vehicle?
I can take this one. Not really. It all depends of how much of the field of view you would like to cover, right? If you have a large car, for instance, there's a chance that you're going to need 4 cameras, but it all depends, again, of how much you would like to cover when it comes to the instruments of the car. Aaron, would you like to add something to the
Yeah,
answer?
sure. Yeah. To add to that, basically, we had cameras anywhere you want to track somebody. So if it's possible to run a 2-camera system and track in the field of view that you're interested in, that works fine. If the subject begins to look outside of that field of view and we can no longer track them, then we'll place a camera in the area they're looking in order to continue tracking and collect data around their
Yeah.
gaze.
I also want to mention that we also have a feature named estimated gaze. And what this does is when the cameras cannot uh, capture your gaze, we create an estimation of where your gaze probably is. So this is a way that we found to not lose data and to create an estimation of where the subject is looking at.
Perfect. Can you add points of interest to your world model?
Points of interest from what perspective? I guess I would answer the question by saying that we do have. You can create the wireframe model using a tool we have, which is called a laser chessboard tool. It's included with your installation when you purchase the tool. And what this allows us to do is measure the actual dimension of the real world. So here we can see on the bottom of the video that we created this wireframe model. Each of these objects is named as well. So there's a syntax involved, a little bit of effort, but it's very simple. Once you get one model created for a vehicle, then you don't need to recreate it. And what we have in this example is we have left mirror, right mirror, we have center console, rear view mirror, windshield, tachometer, speedometer, and a little subsection between those two. And this is what the subject in this case was, or what the proctor of the exam was interested in looking at the subject. Anytime that the 3D world model lights up red, we can see that that's the object they're looking into. In this case, the subject was currently looking out the front windshield. But as they go through the various objects, you'll see that they will light up. So I think they'll move through the various mirrors. There you go. So on the driver's side mirror, speedometer, centerpiece, the tachometer, and the various objects update. So with respect to being able to track points in space, this is how we do it. We basically build a 3-dimensional model and then track where the subject's looking on that, not only in 3 dimensions. So we do provide the data 3-dimensionally X, Y, Z relative to the coordinate origin, but we also provide the data relative to the surface. So if it's a plane, for instance, we'll also give you the X, Y coordinates from the bottom left corner of the plane in this example.
Okay, we just had another question come in. How would your system evolve when it comes to commercial vehicle platforms? So, for example, trucks and buses.
Sure. Yeah, so there's not really a big difference between automotive and truck and bus, just that the environment can be a little more harsh as far as a vibration goes, vibration and shock. But otherwise, camera placement works much the same way. So as long as we have cameras that can collect the gaze of the subject, regardless of where they're looking, then we can track them. So the really nice thing I hope that the webinar was showing off is that our camera system is a bit environment agnostic. You can take a camera system that you own from, let's say, a small automotive vehicle and take the same exact camera system, move it into a different environment, create that environment in the wireframe model, and then track on it in the environment. So long as we can capture the head and especially the glints that Mario mentioned. So we do have the infrared light that we produce. As long as we can capture those glints on the corneal surface of the eye, then we have very, very precise tracking. Again, as he was mentioning in part of his answer earlier, if we can't capture those glints on the eye, then we have a fallback mechanism, which we call our estimated gaze. And the estimated gaze uses just base pupillometry, which is taking into account what the cameras can see of various features of the head of the subject as well as the eyes. So the only difference when it comes to automotive versus commercial vehicle is just basically a size difference. There's potential we might have to include an additional camera because the vehicle's larger with a bigger cockpit. But in my experience, that hasn't necessarily been the case.
Okay, another question. Is it difficult to calibrate the system? Can you talk a bit about that process?
it's very easy. We have two types of calibrations. We have the system calibration and we have gaze calibration. The system calibration, it's very easy to perform. It takes no more than 15 seconds, to be honest. There's a chessboard that we use, and we just put on the same height that you have your face, and you go like this. It would be better to actually show how it works, but it's very simple. It's a very simple process. For the gaze calibration, it's also not complicated at all. Once you have your points of interest, right? We start calibrating each one of the points, and that is a process that takes no more than 2 minutes per se.
I think the only thing I would add is that the gaze calibration points will be added into the world model file as well. So we'll use the same laser chessboard tool to collect those points in three-dimensional space, and that helps us more accurately detect where the subject's looking and how close they're looking to that object or that point in space.
I had another question. You mentioned earlier in the webinar when you were introducing the company about iMotions. I was wondering if you could talk about kind of working together with them. What does that look like? Is there any additional things you can talk about with regard to how they collect data, how we collect data, or any of that kind of stuff?
Yeah, sure. I can handle this question. Awesome. So as I mentioned when I was presenting a little bit about iMotions, they consider SmartEye Pro more of a sensor. So as a biometric platform, they take in many different sensors and they collect all the information, flatten it, and timestamp it so that it's easy to go through and analyze after the fact. So from a SmartEye Pro perspective, we would output the data over an Ethernet link generally, or if the two pieces of software are running on the same PC, we can do it internally, but it's still via Ethernet, just be a virtual Ethernet link. And then iMotions will collect the SmartEye Pro data. It'll also ingest the SmartEye Pro world model that we've been talking about, and it will display that in their tool. We can also couple this with our Affectiva AffX database as well, which will allow you to use a subject-based, or they call it respondent-based camera, that will track the emotions based on facial features of the subject. We can combine that with an environment-based camera, which would track the interior environment of the automobile. So that would maybe be more of like an over-the-shoulder style camera. And we can also have a third video-based camera, which is similar to what we showed in the video of looking out the front of the vehicle and tracking where the subject is looking out into the environment. As far as the data goes, all of the data that's in SmartEye Pro is available inside of iMotions. It is graphable, and it's easy to do annotation. I can mark up a section of iMotions, for instance, to say I was making a turn, or if you're in an aircraft, we were dipping the left wing, or we were nose up, nose down, takeoff, landing, things like that.
Yeah, I just want to say that iMotions also gives you the ability to create heat maps, for instance, in gaze path, which is something that we often see customers looking for. It becomes a very powerful solution when you have iMotions, SmartEye Pro, and Affectiva. It becomes something amazing.
Cool. We just had a couple more questions come in. So the first is, do you have any KPIs to your head pose and the gaze accuracy?
If you're talking about parameter indicators for the head, we use various facial features to anchor the head in space, and triangulation using the glint on the eyes to understand where it exists relative to the origin that we've created in the system. So for head pose, we use corners of the eyes, corners of the mouth, nostrils, ear, and we create a three-dimensional origin within the head and basically reference that origin to the coordinate system origin of the world model for accurate head tracking. When it comes to gaze accuracy, that goes back to what Mario was just mentioning, that we can put various points in 3D space. We know where those points exist relative to our origin again. And then we track the subject by having the subject look at those various gaze points. And we collect left eye versus right eye and create a combined accuracy across the entire field of view based on where the subject has looked at those points relative to where those points actually exist in space. So what we're really looking for there is precise eye gaze by the subject, and then we account for the accuracy. We basically fix the accuracy with an offset.
All right. Another question. for trucks. So will one camera suffice, as the installation would be mostly on a pillar? When then it can track only one eye gaze. How would you see that for buses? So I guess this is a series of questions. For buses, if there are multi-head in the FOV, then how does the system recognize the subject?
So I can answer the last question first. In any system, if there are multiple people involved, the system creates a profile, a head model for each person individually. So it, again, kind of going back to what I was mentioning in the last answer, it collects data around the eyes, the nose, the mouth, the ears, etc., and it knows where all those pieces are relative to one another. So my eyes, my nostrils, my corners of my mouth, my ears are different from everybody else, as you can see in this video as well, from Mario and from Ashley. And so we're able to use that information to create a unique head model for each subject. That information would then be saved into a profile. And the other piece of data in that profile would be the gaze data that we've collected from performing the gaze calibration on that subject. So the other part of the question, I think, is a little bit more difficult to answer just on a webinar. And I would suggest that possibly this person contacts us so we can speak and maybe present a live demo or something for them.
Great. And I think that is just about all we have time for. I want to thank our presenters, Mario and Aaron, once again for making the time to share all of this with us today. Hopefully this gave some clarity on the amazing work that Smart Eye is doing for automotive research. Follow us on social media or sign up for our newsletter so you don't miss our next virtual event. And thank you, everyone, and have a great rest of your day wherever you are in the world.
Thank you, everybody.
Whether you're a part of a university lab, an automotive researcher, or simply passionate about the automotive industry, this webinar offered a unique opportunity to explore the cutting-edge technology shaping the future of automotive research. From human-centric mobility insights to unobtrusive flexibility, I encourage you to download the video recording linked in the show notes to see the accompanying visuals, including video, that helped show how our advanced eye and head tracking technology offers a unique window into human behavior, cognition, and emotions inside vehicles. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Spotify, Amazon Music, or wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag HumanCentricAI Podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.